Okay, the next unit, we're going to start using trigonometry to find the integrals. And so let's just review a little trigonometry here. So aim is using trigonometry to find integrals. Just some review. We know from the unit circle. That the x is cosine of theta, and the y is sine of theta. And so, if this were a unit circle, right? We have the idea that sine squared plus cosine squared equals 1, and then we can also create some other theorems. So, for example, what we can do is divide everything by sine. I'm going to use S and C because I'm lazy. Can you see me that far away? Should I move it up? Let me move it up a little bit more. There we go. So I'm going to divide everything by cosine squared. And so I get tangent squared plus 1 equals secant squared. And if I take the same thing, my same Pythagoras identity, and divide everything by sine squared, right, I get 1 plus cotangent squared equals cosecant squared. So I'm going to need some of these. The other thing we learned last year is that these double angle formulas. You learned that sine of 2 theta is equal to sine theta cosine theta. But more importantly, you learned last year that cosine of 2 theta is equal to 2 cosine squared theta minus 1. You also learned that, let's manipulate this right now. So, if cosine 2 theta equals 2 cosine squared minus 1, I could say that cosine 2 theta plus 1 divided by 2 is equal to cosine squared theta. Okay? Or, we also learned last year that cosine 2 theta is equal to 1 minus 2 sine squared theta. And if I manipulate that, I get, let's see, we have sine squared theta. So I'm going to move the cosine 2 to the right. I'm going to move the negative 2 sine squared theta to the left. And so I have 1 minus cosine 2 theta divided by 2. Okay, well, we're going to see that all of these show up. So let's start with, we're going to be looking today at the powers We're going to be looking at the powers of sine, cosine, and tangent. So let's start off with the first degree. So with the integral of sine theta, d theta, we know is negative cosine theta plus c. How about the integral of cosine theta, d theta? Well, we already know that that's sine theta plus c. The last thing is tangent of theta d theta. Does anyone recall our technique? Well, we're going to rewrite this as the integral of sine over cosine d theta. I'm lazy. And what we recognize is that the derivative of cosine is the sine. And we know from the manipulation of the differential that it's going to end up, the derivative is going to end up in the denominator. So we're going to let u equal cosine theta, and therefore du over d theta is equal to negative sine theta. So du over negative sine is equal to d theta. We're going to make the substitution, the integral of sine theta over u times du over negative sine theta. We have the integral of negative 1 over u du, which is equal to negative ln of u plus c, which ends up being negative ln of cosine theta plus c. But in the formula book, because they don't leave it as negative ln cosine, you know from logarithms we bring the negative up there, and it becomes ln secant theta plus c. Okay, let's move on. I'm going to keep these up here. So that's our first degree. Good, I have plenty of room. Next, I want the integral of sine squared theta, d theta. Well, in this case, any suggestions? Well, you can see here that I transformed sine squared theta into 1 minus 2 cosine 2 theta. We can see if we can get these powers into, just, degree, multiples of an angle, that's really easy for us. Let's look at this. So we know we're going to substitute. We have 1/2 minus cosine of 2 theta over 2 d theta. And we're like, okay, well, we're in luck there because I know the integral of 1/2 is theta over 2. And I know the integral of cosine 2 theta is sine 2 theta divided by 2. Remember, we did the substitution. I want you to do this on the side. So take, if u equals cosine, if we let u equal 2 theta, then du over 2 equals the theta. So the 2 comes down. So this is minus sine 2 theta over 4 plus c. Try this out on your own. This idea, it's really easy. Once you just bring the cosine back, but remember the 2 goes in the denominator. What's going on with the integral of cosine theta, d theta? Well, it's the same idea. It's the same idea. This is equal to the integral of cosine 2 theta over 2 plus 1/2 d theta, which we know is negative, same idea. Sine 2 theta over 4 plus theta over 2 plus c. Next. What's next? Tangent. The integral of tangent squared theta. Well, this is easy also. What substitution can we make? Do we want to, we say, oh, you know what? We know that tangent theta is secant theta minus 1. And you say, oh, you know what? I know the integral of secant squared. And that's basically it. The integral of secant squared is tangent theta minus theta plus c. So that's where all these trig, that's the purpose of all that trig, is that it shows up here in the integration. You just should know how to do this. College professors, I'm assuming that they'll make you just sit through this. Maybe they will, maybe they won't, but you sat through this in my class. Let's go and deal with, what do you think? Well, let's start with tangent cubed. What do you think? Well, these are old techniques. You can investigate. The idea is you're going to factor out a tan. Okay, and then what you're going to do is you're going to distribute it through. Oh, no. We're going to make a substitution here. Then we're going to distribute. And then what are we going to do? Well, what's the derivative of tangent? It's secant squared. So once it comes back to that substitution unit. Can you see everything in there? Sorry about that. Yeah, the same idea is substitution. You go, oh, you know what? The derivative of tangent is secant squared. So on the side, we're going to let u equal tan du over secant squared equals d theta. The integral of u secant squared du over secant squared minus the integral of tan theta d theta. And now but we can kind of go through this. The secant squareds cancel out. We're left with u du. What's the integral of u? It's u squared over 1/2 minus what? Oh. Minus ln of secant theta plus c. Final answer, tangent squared theta over 2 minus ln secant theta plus c. This is the idea. It's this constant buildup. You're doing all this trig, and you're just slowly building up, and you're just applying all this stuff once again. This is a technique. You're not asked to memorize this. I'm just putting it out there. This is how we do it. So this is the answer. Let's move on. Let's move on to the third powers, and then we're going to stop the video. Well, we just started with the third powers. Now we just want to finish up with the, let's see, what is the integral of sine cubed? And I want you to think about that. How do we, let me move my camera over. Sorry about that. Oh, we're good. How do we find the integral of sine cubed? Well, so actually odd numbers are really easy. What you're going to do is you're going to pull out a sine, leaving us with sine squared theta. And then we're going to rewrite sine squared theta as 1 minus cosine squared. And what do we notice? Well, if we let u be cosine, the derivative knocks out the sine. So let u equal cosine theta. So du over negative sine theta equals d theta, right? Sorry about this, d theta. And so we have sine theta. No, sorry. Yeah, d theta, sorry. So we have sine theta over 1 minus u squared times du over negative sine theta. These go out with this, right? And we're done. We have the integral of u squared minus 1 du, which is u cubed over 3 minus u plus c. And we said that this, u was cosine, so we have cosine cubed over 3 minus cosine theta plus c. I'd like you to try cosine cubed on your own. It's the same technique. So, integral of cosine cubed theta. Same idea. I'd like you to try it on your own. Let me move the camera over. Okay. So, I paused the video. Now I'm back. So, same idea. Pull out a cosine theta, leaving us with the cosine squared theta, d theta. And so we have the integral of cosine theta, 1 minus sine squared theta, d theta. We're going to let u, can you see that? Yes, we're going to let u equal sine theta. So du over cosine theta equals d theta, and we can make our substitution. So we have cosine theta times 1 minus u squared times du over cosine theta. The cosines knock out. Good. So we have u minus u cubed over 3 plus c. Final answer, sine theta minus sine cubed theta over 3 plus c. Now, you might be asking yourself, well, can I do higher powers? Can I do the integral of sine to the 8th? Now, odd powers are easy. Well, but they're not really easy, because if you think about it, like if I do sine to the 5th, I can pull out a sine, right? And I'm left with, I can do sine squared. Let's do sine to the 7th. So I can do sine squared to the third, right? And I can do the same technique. So I have sine of theta times 1 minus cosine squared to the third. I can do the substitution. So after the substitution, I'm left with 1 minus u squared to the third power. And that starts to get a little ugly. So in the next lesson, we're going to talk about how we can introduce complex numbers into this to make this all easier. So in the book, you're going to really go back and really manipulate your trigonometry. I'll give more instructions in the Google Classroom assignment.